Hey guys, what's going on? So today we are going to be talking about complex projective spaces. This is within the playlist of quantum gravity. The reason I'm doing this is just to get us a little bit deeper into complex manifolds because we're going to be dealing with them later. In this video we're also going to be looking at a couple of theorems behind complex manifolds and a few examples. So without further ado, let's get straight into the content. Again, make sure to hit that like and subscribe button, and now let's get into it. Okay, so we're talking about complex projective spaces. Again, also if you're interested in supporting the channel, you can go to my Patreon page and you can go on to you can become a member of this channel here on YouTube, and just want to run that out there before we start. So we're initially going to run into a problem here with complex spaces, because on the one hand we could take a complex space and we can define it for every point on one half of, say, a sphere. Okay, this is a topologically interesting object, and we could say, well, we could take some mapping A to Cn on a sphere of n dimensions, and we can place this mapping, we can cover it on the top of the sphere, and we can say, well, we can define everything to be a complex number on the sphere, and we can do the same thing for the bottom of the sphere. What happens though is that at the equator you have an undefined region, okay? And that undefined region is undefined because you have a complex plane on one half of the sphere and the complex plane on the other half of the sphere, and they meet at the equator. And so the points on the equator themselves are not points that are clearly defined in terms of one or the other complex field that we're sort of wrapping in this sphere. Okay, and so what we end up having to do is overlap these just a little bit so that we can get so that the equator can be defined. But then what happens is we run into a problem. If we try to take a vector field, okay, and we try to wrap that field around the entire sphere, covering everything, we inevitably run into a problem where things sort of, the vector fields, I say hair because this is known as the Harry-Sphere theorem, the vector fields eventually spiral into a point, that point being on the overlap itself, and you get this sort of Cowlick effect. Okay. Again, this is as I just mentioned, this is known as the Harry-Sphere theorem, and what we end up having to do is we end up having to say, well, just like we did in the last video, we can take some transition function, or some transition function phi b, where it takes us from a point on the manifold B. So the point on the manifold B, and here's A, so there's atlases on the manifold, and what ends up happening is we can we apply this mapping to get us to Cn. From Cn, this is associated. Hey guys, what's going on? If you're interested in this video and want to learn more about loop quantum gravity, string theory, and so forth, what you can do is you can become a member of this channel, and you can gain access to all the videos that become uploaded on this topic and future topics as well. Again, thank you so much for your support, and thank you so much for watching. This channel keeps on growing and growing, and I'm very excited to see where this is going to go in the future. So with that being said, make sure to hit that like and subscribe button if you like this kind of content. Make sure to become a member as well. Thank you, and bye.